Hey guys, your 1.5 video is over solving equations. Remember, equations are expressions that will have an equal sign in between. So the first part of solving equation will be over quadratic. Why don't we just start by solving quadratic? All right, for quadratics, every time you say quadratic, you think of the standard form of the equation. And the standard form of the quadratic equation is ax squared plus bx plus c. Of course, that's the standard form. I should write standard form. And beside the standard form, you also think of two other elements. The first one is what we call the quadratic formula. So you can use the quadratic formula, you can factor. So there are so many ways. So the first one is the quadratic formula. Using the quadratic formula, you can solve a system. What exactly is the quadratic formula? The quadratic formula is x is equal to negative b plus or minus square root of b squared. Actually, I want to write this in a different column. Square root of b squared minus 4ac that I divide by 2a. The reason I wrote this portion in red is because this is actually what we call the discriminant. How important is the discriminant? The discriminant is important in a way that if b squared, if the discriminant is positive, meaning b squared minus 4ac is greater than 0, you will know that you have two real solutions. That's the first case. The second case is in case b squared minus 4ac is equal to 0. Therefore, you have exactly one real solution. But if for any reason you have b squared minus 4ac is less than 0, you will have two complex, two imaginary. I can call them complex, I can call them imaginary. It's up to you how you want to call them. All right, that's using the quadratic formula. Another way to solve it is by factoring. You can just factor it. So factor, use the quadratic formula. In Algebra 2, you also learn how to complete the square. Besides completing the square, you can also use the calculator to solve it, and that will be by graphing. Of course, by graphing, that's when you plug in on the y1, y2, and find the intercept. So graphing will require you to find zeros, intercepts, all the solutions. All right, let's go ahead and do one example of the quadratic. Here's my example. For the quadratic, I will give you an equation such as 2x squared minus x minus 1/2 is equal to 0. Now, I will go ahead and use first of all, with the 1/2, it makes it very complicated. So you can multiply everything by 2 to get 4x squared minus 2x minus 1 equal to 0. From here, if I want to factor, I will say find two numbers that the product gives you 4 times negative 1 and the sum gives you negative 2. Well, that's one way. Or I can use the quadratic formula by saying, well, a is equal to 4, b is equal to negative 2, and c is equal to negative 1. If I want to plug in into the quadratic formula, I would say x is equal to negative b, meaning 2, plus or minus square root of b squared, meaning 4, minus 2ac, minus 2 times, or let me go ahead and plug in the way it looks. So I can say it's negative of negative 2, plus or minus negative 2 squared, minus 4ab, meaning 4 times 4 times -1 for AC over 2A, meaning 2 times 4. Well, if you simplify this one, you will get 2 plus or minus square root of 20 over 8. And that's 2 over 8 plus square root of 20 over 8. By the way, square root of 20, in case you didn't know, this is the same thing as 2 square root of 5. So if you want to simplify this, you will say this is actually 2 over 4 is 1/4 plus or minus 2 divided by 8 is 1/4 again, so that will be square root of 5 over 4. And this is the final answer. That's it, of course, using the quadratic. You can use any method you wish to. The next one, the next expression we will try to solve will be rational equations. For rational equations, where did it go? For rational equation, I will give you this example. Well, to solve this rational expression, the first thing I will try to get rid of is this long denominator. So to get rid of this 2 denominator, I will multiply the whole expression, including the 1, by the common factor, the common denominator, which is 2x plus 7 and x plus 3. On both sides, this also by 2x plus 7 and x plus 3. Once you complete this, you will have on the left side x minus x plus 1. And on the right side, you will have, by the way, this fraction, this first one will keep the x plus 3. And this other portion, we keep the 2x minus 7. 2x plus 7. And of course, the last one, we keep everything, meaning 2x plus 7 and x plus 3. I know you can go ahead and do it by yourself, but I'll go ahead and walk through the steps. That will be x squared plus 3x minus x. Very important is, I'll need to distribute this first before I apply the negative. So it's actually minus 2x squared. And again, I'm assuming you know how to multiply. 2x times x will be my 2x squared. And now we have 7x plus 2x plus 7 is equal to, this one will be 2x squared plus 6x plus 7x plus 21. From here, I will combine like term. If you notice, this negative will distribute, and I'll be left with negative x squared. I have a 3x here, minus 7x minus 2x will leave me with negative 6x. And I have this negative times this 7 will give me negative 7. On the right side, I will have 2x squared plus, combining these two will give me 13x, and I still have the 21. Well, I can move everything to the right side and say 0 is equal to, moving this here will give me 3x squared. Moving the negative 6x to this side will give me a 19x. And moving the 7 to this side will give me 28. Well, at this time, I can use various methods to factor it or to solve it. But I'll try not to use a calculator. I'll do 3 times 28 is 84. two numbers that the product gave me 84, the sum gave me 19. That would be 12 and 7. 12 and 7, yes. But of course, if you think of 2 and 42, it will not add it to be 19. Or if you think of 21 and 4, it will not add to be 19. So I will rewrite this expression. This expression will now be 3x squared plus 12x plus 7x plus 28. Combining the first two elements, I will have 3x in common, and I have x plus 4, plus 7 in common, and x plus 4. So if I keep going here, I will have 3x plus 7 times x plus 4. Note that it's still equal to 0. So to solve this, I will split it and say 3x plus 7 is equal to 0, or x plus 4 equals to 0. Well, if 3x plus 7 is equal to 0, it means that x is equal to negative 7/3, or x is equal to negative 4. And this one is your solution, or these are your solutions. Now, sometimes you get these solutions, but they're not quite solutions. They are called extraneous solutions. To check if you have any extraneous solution, always plug in what you get into the denominator of your fraction. Imagine I plug in negative 4. By plugging negative 4 on the bottom here, none of them will turn into a 0. So those two are solutions. Same thing with negative 7/3. So always plug into the equation to make sure they are not extraneous solutions. Now, the next one will be absolute value. So let's go ahead and have absolute value. All right, for absolute value, you always have to split them in two. So let's go ahead and look at an example. Here, for example, I have absolute value of 3x plus 5 is equal to 1. Well, that's possible. It means that 3x, you always split it in two. The positive side, we say 3x plus 5, or let's start with the negative, is equal to negative 1, or 3x plus 5 is equal to 1. Because the absolute value of negative 1 is 1, and the absolute value of 1 is still 1. And you will solve them separately. All right, so let's go ahead and solve this one. I will have 3x is equal to negative 6, or 3x is equal to negative 4. So x is actually equal to negative 2, or x equal to negative 4/3. And this one will be your solution. Now, what will happen if I give you something like this? If I give you absolute value of 3x plus 5 is equal to negative 2. Well, the absolute value can never be negative. If I give you something like this, you will say no solution. But as we did before, it's always a good idea to check for extraneous solutions. So you will always plug in negative 2 here, see if you get something nice, and plug in negative 4/3 and see if you get something nice. And if they both equal to 1, then both of them are solutions. All right, our next one will be radicals. So let's go ahead and do radicals now. For radicals, I will start by, of course, an example again. So here's the example. The example will be square root of 5 minus x plus 1 is equal to x minus 2. Of course, radical means we have the radical there, not necessarily that all the expression is inside the radical. But the first thing you have to do is isolate the radical, meaning square root of 5 minus x is equal to x minus 3. Once you isolate the radical, now you square both sides to get. So what I will do is square both sides. And if you square both sides, you will end up with 5 minus x is equal to x squared minus 6x plus 9. I'll move everything to the right side to get 0 is equal to x squared minus 5x, and 5 on this side plus 4. Well, this is an easy one to factor. That will be x minus 4 and x minus 1 is equal to 0. So my two solutions will be x equal 4 or x equal 1. Now, once you get your solution, you always have to check for extraneous solutions by plugging it back into it. So these two are my solution. For example, if I plug in 4 here, I get 5 minus 4. Well, inside the radical, it's not something negative, so it's a solution. So always check for your extraneous solutions. Besides radicals, we need to be able to also solve for, let's go ahead and now solve for little equation. So I will have by the way, this is A. But let's insert it. It's not little rod, but it's little rod. So here I need an A. This is an A. Little rod equation. Little equation are equation that we have a lot of letters involved. Example, I can have AX minus M over CX minus D is equal to 2. And I can say solve for X. In this case, I will first cross multiply, have it over 1. It means AX minus M is equal to 2 times CX minus D, which is the same thing as 2CX minus 2D. From here, since I'm solving for x, I want to isolate that x. So I will move this on over here and move the m on this side. So I have ax minus 2cx is equal to m minus 2d. From here, I can factor an x out to have a minus 2c is equal to the same m minus 2d. At this point, I will divide both sides by a minus 2c to get x is equal to m minus 2d over a minus 2c. And this one is your answer. Well, this is the value of x. Well, although this is the answer, another person could have get a different answer. Well, it's different, but it's still correct. In case you factor a -1 on top and on the bottom, you will end up with -1 times negative m, or 2d minus m over -1 times 2c minus a. And if I simplify the -1, this one gives me another answer, which is 2d minus m over 2c minus a. This is correct just as much as this is. So you can write this one or this answer. All right. The only thing I can tell you now is you should always check for extraneous solutions. Always check for extraneous solutions, because sometimes it might look like a solution, but it's not a solution. It's not a solution once you check.